Hey guys, welcome back. So today we are going to talk about solving rational equations. So the first set we have is the simplest version is if the denominators are the same on both sides of the equations or across all the fractions. So if the denominators are the same, the only way to make these two fractions equal to each other is if their numerators are also the same. So both denominators are 2x plus 7. So what that means is I can go ahead and ignore the denominators altogether. All I have to do is take the two numerators, 3x plus 5, and set them equal to each other, 5x minus 2. Now this is a simple two-step problem. Actually, it's more like 3 steps. We're going to go solve this guy, so that means I'm going to move all my x's to one side of the equal sign. 5 equals 2x minus 2. Get rid of the constant. Add 2, add 2. 7 equals 2x. And then divide by the coefficient. So in this case, the number that makes both of these fractions equal is x equals 7 over 2. So example 2 is going to be the same. Look at the fractions all the way across. So in this case, we have x minus 1 on both, so that means that to make these fractions equal, their numerators have to be equal to each other. Okay, solve a multi-step problem. So add x to both sides to get all of your x's together. So this makes 4x minus 1 equals 3. Then add your constant to the other side, plus 1. So 4x is equal to 4. Then divide out the 4, x is equal to 1. Then we have examples for section 2 that require a little bit more effort. So the first way you can solve the ones that don't have common denominators is with cross multiplication. Now, cross multiplication is used when each side of the equation is a single rational expression. So there's one fraction equal to another fraction. So example number 3, we have 3 over x plus 1 equals 9 over 4x plus 5. So what we have here is we have one fraction equaling to another fraction. This is what we call a proportion. Well, the way you guys solved proportions in 8th grade was you used what we call cross multiplication. So we took this 3 and multiplied by the denominator. So 3 times 4x plus 5. I need parentheses because 4x plus 5 is stuck together. It's not just 3 times the 4. I have to do it to both. Then we're going to put an equal sign. And then we're going to multiply the denominator to the other numerator. I'm going to put the 9 on the front because that's usually where we put the constants. So this is what we have now. So cross multiplication lets us get rid of those fractions and makes it a little bit easier for us to actually solve. So now we're going to solve a basic equation like we would back in Algebra 1. Distribute in your 3. 12x plus 15 equals, distribute in the 9. 9 times x makes 9x. 9 times 1 makes 9. Solve a basic multi-step equation. Move your variables to one side, so minus 9x from both sides. 3x plus 15 equals 9. Subtract 15, move your constant. So I got 3x is equal to 6, negative 6. Divided by 3, x is equal to negative 2. Now, here's what we always need to do with these. So there is one number that we're not allowed to divide by, and that number is 0. So before we can stop and say that this is in fact our answer, we need to check inside the denominator. Make sure that it doesn't make any of the denominators equal to 0 because that means that x equals negative 2 wouldn't actually be a solution. So we can do this one in our head because this one's short enough. So if x is negative 2 and I substitute it into this denominator here, I would have negative 2 plus 1, which makes negative 1. So that one's okay. Let's plug it into this one. 4 times negative 2 makes negative 8 plus 5 makes negative 3. So that is also not 0. So, since x equals negative 2 doesn't make any denominator 0, this is in fact our solution. Always make sure you check it back into the denominator. Let's try this one. If you want, pause the video yourself and see if you can solve this one on your own, or at least get it cross multiplied. So in this case, when I cross multiply, I'm going to do x times 4x plus 1. equal to 2x plus 2 times 2x minus 3. So in this case, we're going to have a binomial times another binomial. So multiplying the first one is just straight distribution. X times 4x makes 4x squared. X times 1 makes an x. Then the second half of this, we're going to have to do double distribution. So 2x times 2x makes 4x squared. 2x times negative 3, negative 6x. 2 times 2x makes 4x. 2 times negative 3 makes negative 6. Before you start moving things across the equal sign, let's go ahead and clean up the right-hand side. So the left-hand side is going to stay the same, but my right-hand side, I can combine negative 6x and 4x to make negative 2x. Okay, so now let's start moving things across. So I'm going to move my x squareds first. So I'm going to subtract 4x squared from this side and this side. And if we notice, in this case, both of these are going to add to 0. So all we have left is x equals negative 2x minus 6. So continue solving. Add 2x to both sides. We get 3x equals negative 6. Divide by 3. X is equal to negative 2. So once again, before we can say that this is our final answer, we need to check into the denominator. Numerators can be 0, that's not a problem. The denominators cannot. So again, let's just do this in our head. So negative 2, let's plug that in up here. So 2 times negative 2 makes negative 4, plus 2 makes negative 2. So this one is not 0, so we're good so far. So let's plug this one in again to this guy. So 4 times negative 2 makes negative 8, plus 1 makes negative 7. Also not 0. Therefore, this is in fact our solution. X is equal to negative 2. So far we have, if the denominators are the same, just set the numerators equal and solve. If they are not the same, but I only have a single fraction, then we need to be able to cross multiply. What happens if I have more than one fraction on one side? Well, this is what we have to solve using by what we call the lowest common denominator. Okay, so what we're going to do is we're going to multiply each side of the equation by what we call a least common denominator in order to kind of get rid of our fractions. So let's look at example number 5. Solve 5 over x plus 7 over 4 equals negative 9 over x. So before we can do this, we have to figure out what our least common denominator is. So we're going to abbreviate that as LCD. So what do we have? So in our denominators so far, this one has an x, this one has a 4, and this one also has an x. So think about adding these fractions together. We would need a 4 and an x in all the denominators in order to add them up. That's what the LCD is. So our LCD is going to be 4x. So what we're going to do is we're going to multiply every one of the fractions by this 4x to help us get rid of those fractions. So we're not going to do a fancy form of 1, we're just multiplying by 4x. So the first fraction, we're going to multiply by 4x, so 5 over x times 4x. We're going to multiply the second fraction by 4x, and we're going to multiply this third fraction times 4x. Now, here's, oops, that should be an x, not a 4. Let me fix that. So now, here's what happens. So when you multiply, remember, this is really 4x over 1. Anything over itself cancels out into a 1. So this x and this x are actually going to cancel out, and what you're left with is 4 times 5. Then on the second fraction, this 4 and this 4 are going to cancel out, and you're just left with 7 times x, or we can write that as just 7x. Then equals, on the other side, you're going to have another x over an x, and those are going to cancel out, and you're left with 4 times negative 9. So we really got rid of all of our fractions. So now let's multiply to clean this up. So 4 times 5 makes 20. Plus 7x equals negative 36. 4 times negative 9. This is a simple two-step equation. Subtract the 20. 7x is equal to negative 56. Divide by 7. X is equal to negative 8. Okay, just like before though, we need to take this solution, we need to check it in the denominators. Check in the denominators. Make sure it doesn't make anything equal to 0. Luckily, this one's really simple. If I substitute negative 8 in for x, well, I just get negative 8. Well, that's not 0. This doesn't have an x. Substitute it into this one as well. Negative 8 into x makes it a negative 8, and so it's not a 0. So this is, in fact, our final answer. Let's try the next one. So example 6, solve 1 minus 8 over x minus 5 equals 3 over x. So first of all, make everything a fraction. So this 1 is going to be actually 1 over 1. Then we have to find what our least common denominator is. So what would all the denominators be in order for them to be the same? So let's look and see what we have. So this is a 1, so this can be changed into anything. So that makes life a little bit easy. This guy right here is x minus 5, and this one's an x. So in order for these to have the lowest common denominator, I'm going to need x and x minus 5. I need them both. So we're going to multiply everything by this in order to get rid of my fractions. So we're going to have x times x minus 5 times the 1. Now, with this subtraction, subtractions can make life a little difficult. So what I want you to do is I want you to pull this negative up to this numerator here. So really, it's like adding a negative 8. So we're going to put a plus x times x minus 5 times negative 8 over x minus 5. That way it makes, you're not having two negative numbers next to each other. Then we're going to have equals, and then I still have to multiply this last fraction times x minus 5 as well. So now that everything's being multiplied with to my lowest common denominator, we're going to see if I can maybe get rid of some stuff. So in this first one, you don't have anything, there's no fraction to get rid of. Well, x times x minus 5 times a 1, that's just going to leave us with x times x minus 5. I can't do anything with that. But this guy, I can get rid of this x minus 5 because anything over itself is a 1, and all I'm left with is x times negative 8. Then, same thing on the right-hand side. This x and this x make a 1, so we're left with 3 times x minus 5. All my fractions are gone. Now I just need to solve this crazy thing. So let's simplify it first before we start actually solving. So x times x makes x squared. X times negative 5 makes negative 5x. X times negative 8 makes a minus 8x equals 3 times x makes 3x. 3 times negative 5 makes negative 15. I'm not going to be able to get rid of my square this time like I did back in example 2. So let's leave this guy as positive because we're going to have to factor this eventually, and I can't factor with a negative x squared. So let's start cleaning this up. So first things first is I'm going to combine like terms. X squared minus 13x equals 3x minus 15. Now, in order to keep my x squared positive, I'm going to move all the right-hand side stuff. So I'm going to do two things at once. I'm going to subtract the 3x, and I'm also going to add 15 to both sides at the same time. Since there isn't a like term with 15, I'm just going to put it way out to the side for now. So I've got x squared minus 16x plus 15 equals 0. Okay, solving this equation, if there's an x squared, you're going to have to factor in order to solve it. So I need my AC method because there's 3 terms. This one's going to be short though because a is equal to a 1, so I can use my shortcut. So a times c, 1 times 15 makes 15, and I have to add up to be a negative 16. Well, if I do 1 times 15 and I add those up, that's a 16. So it's the right number, wrong sign. So that means I need to switch both of these to be negatives. Negative 1 plus negative 15 equals my negative 16. So since a is equal to 1, I can use my nice shortcut. I'm going to have x minus 1 for one of the factors times x minus 15 for the other factor equal to 0. Now that you've got it factored, you're going to take each factor individually and you're going to set it equal to 0. And solve. So on the first one, add 1 to both sides, x equals 1. On the second one, add 15 to both sides, x equals 15. Now, just like in all the other ones, you have to make sure that these do not make any of the denominators equal to 0. So I'm going to have to use my equation way back up top, and I'm going to have to substitute in. So x equals 1. If I take x equals 1 and I substitute that in, 1 minus 5, well, that's going to be a negative 4, so we're okay there. Substitute a 1 into this fraction, and I just get a 1, and that's not a 0. So far, x equals 1 is in fact a solution. Now let's check the other one. Take 15. 15, plug it into the denominator. 15 minus 5 makes 10, so that's good. Plug 15 into this one, and that just gives me 15. Well, that's not a 0. So this is also a solution. So in this case, I have 2 solutions instead of just 1. That is a possibility. All right, let's go to the left part. So here's why we're checking. So we have something called extraneous solutions. We've talked about this once before when we did square roots. So extraneous solutions are those things that look like solutions, but when you substitute them back in, they don't make something that's mathematically possible. In this case, dividing by 0. I'm not allowed to do that mathematically. So that's why you always need to check your solutions by substituting them back into the denominators. Numerators are not a problem. It's the denominators that are the issues. So let's try this number 7. See if you can figure out what that LCD is. Go ahead and pause it, try to figure out the LCD, and then start the video back up again. All right, our LCD. We have, in this first fraction, I've got x minus 3. This one I have an x, and this one I have an x minus 3. So what they all need for them to be the same is they all need an x, and they all need an x minus 3. So that's what I'm going to multiply all of these fractions by. So we've got x parenthesis x minus 3 times 2 over x minus 3 plus x times x minus 3 times 1 over x equals x times x minus 3 times x minus 1 over x minus 3. All right, now let's see what we can possibly get rid of. So in this first one, we're going to get rid of the x minus 3's, and we're left with 2x. Second fraction, we're going to get rid of the x's, and all we're left with is if you do x minus 3 times a 1, you're just going to get x minus 3. Then on the equal to side, we're going to get rid of x minus 3, so we're going to be left with x times x minus 1. Now, clean it up. Let's go ahead and distribute and combine. So in this case, since this is a positive one, I can kind of ignore my parentheses. So 2x plus an x makes 3x minus 3. I'm going to have to distribute this x out. X times x makes x squared minus an x. Okay, now again, I have an x squared. I'm not going to be able to get rid of it. We need to keep this x squared positive in order to factor. So let's move the left-hand stuff over to the right hand. So I'm going to subtract 3x minus 3x, add 3 to both sides also. So I have 0 equals x squared minus 4x plus 3. Okay, solving a quadratic. You could use the quadratic formula if you remember that from a long time ago, but this is going to factor nice. So a times c, since there are 3 terms, so I have 1 times 3 makes a 3. I need to multiply to a 3 and add to b, which is a negative 4. Well, the only way we're going to do that is negative 1 times negative 3. So this one will work with your shortcut, but let's go ahead and review how to factor by groupings. We're going to split apart this b. So we got x squared minus 1x minus 3x plus 3. Then we're going to take this and we're going to work with 2 terms at a time. So we're going to split this guy in half. So this first one I can take out an x. So that x goes on the side and I have x minus 1 left over. On the second 2 terms, I can divide out a negative 3, so that negative 3 comes to the side, and I get x minus 1 left over. Still have that equal 0. Then, these are like 2 gigantic terms, so we're going to have x minus 1 is one of the factors, and x minus 3 is the other factor. Then, now that I have it factored, we're going to take each individual factor and set it equal to 0. And we're going to solve. So add 1 to both sides. and you're going to end up with x equals 1. Add 3 to both sides, and you get x equals 3. So now that we have this, remember, we don't necessarily have both numbers as solutions. So let's look back at the very, very, very top. So what we're going to do now is we're going to check. We're going to check these guys to make sure that they actually work. Always check your answers back into the denominator. So first thing we're going to check is we're going to check x equals 1. So the first denominator is x minus 3. So if I plug in 1 minus 3, I get negative 2. That's okay. Second denominator is just an x. So if I plug in a 1, well, I get a 1. And that one's good too. So x minus 1 is in fact a solution. So now we're also going to check, x equals 3. So the first denominator was x minus 3. So if I plug in the 3 into that, I have 3 minus 3, which equals 0. This is not okay in the denominator. So this x equals 3 is actually not a solution, because it makes the denominator equal to 0. Because makes denominator DENOM equal to 0. You're not allowed to have the denominator equal to 0. So in this example, you actually only have one solution, and that one solution is x equals 1. This x equals 3 is what we call an extraneous solution. It looks like it'd be right, but it's really not, because I can't have it in my original equation. Let's try one more. Let's solve this guy. So this one's going to be a little crazy because I have this x squared plus 2x hanging out down here on the bottom. So in order to figure out my lowest common denominator, everything needs to be factored out as low as possible. So this denominator is actually x times x plus 2. That's really what that guy is if you factor him out. So now let's see. If I try to find my lowest common denominator, for example, number 8, this first fraction has x plus 2. The second one has x and x plus 2, and this third one has an x. So my lowest common denominator is going to be x and x plus 2. So multiply with that on both sides. So you're going to have x times x plus 2 times your first fraction, 3 over x plus 2, plus x times x plus 2 times my second fraction. And I'm going to use the factored version on the bottom. Then equal to x times x plus 2 times my third fraction. There we are. Now that you've got everything multiplied, let's see if I can maybe simplify some stuff down to a 1 and get rid of it. So x plus 2 over x plus 2 is a 1, so all I'm left with is 3x. Now on this fraction, you notice I have x and x making a 1. X plus 2 and x plus 2 making a 1. So all you're left with on the second fraction is just the 6. Equal to x over x makes a 1. So all I have over here is x plus 2 times negative x plus 3. Now let's solve this guy like we have been doing. Distribute and simplify. So I'm going to have to double distribute over here. So this is going to be negative x squared plus 3x minus 2x plus 6 equal to, and then this side's not going to change because I don't have anything to simplify over here. Before we start moving things, combine your like terms together. So I've got 3x plus 6 equals negative x squared plus x plus 6. Okay, now in this one's negative. So let's go ahead and move all of this right-hand side stuff to the left because I cannot factor if a is a negative number. So we're going to go ahead and get rid of that. So we're going to add x squared minus your x and minus your 6. Go ahead and move everything at once. So now I have a 0 on the right. The x squared doesn't have any like terms, so he's just going to be x squared. 3x minus x makes a 2x, and 6 minus 6 actually makes 0. So what we have is we have just x squared plus 2x equaling 0. This one's actually nice and easy to factor because it's only two terms, which means all we're going to be doing is looking for a common number to divide out. In this case, x squared and 2x only have an x in common. So if I divide that out, I'm just left with x plus 2 equals 0. Set each factor equal to 0 and solve. The first one's already solved for us. X equals 0, that one's done. So let's look at x plus 2. Subtract 2. X is equal to negative 2. Now remember, we have to make sure we check both of these answers. Make sure they actually work. So the first one we're going to check is x equals 0. So let's look back at our original problem and find our denominators. So the two denominators I have is x plus 2, x times x plus 2, and then x. So the first denominator that I have is x plus 2. Well, if I plug in a 0, I get 0 plus 2, which equals a 2, and that's okay. So far, this is an okay solution. Let's try the second denominator, x times x plus 2. So now I'm going to have 0 times 0 plus 2. Well, what is 0 times anything? Well, that's going to make a 0, no matter what. And because I made a 0, that already ruins x equals 0 as a solution. So right now we have x equals 0 as not being a correct solution. Now that doesn't automatically mean that x equals negative 2 is a solution. You have to check both. You can't just assume that the other one's going to work. So x plus 2 was our first denominator. And if I plug in negative 2, well, negative 2 plus 2 makes a 0, and that's not okay either. So actually, x minus 2 isn't even a solution either. Well, I ran out of stuff to check. So since both of the solutions that I got made a denominator equal to 0, there is no solution to this equation because all the solutions that I had made denominators equal to 0. So I can have one solution, two solutions, I could have three, or I can have no solution.